Hello and welcome to some more maths with Mr. Thompson. And today we are doing a speed run on the Level 1 Mathematics 1.4 Prelim for 2025. As the name suggests, this is not a step-by-step careful explanation of all the answers. If you want to get some more details, go and ask your classroom teacher. This is just a fly-through to let you see all the answers, what you should have got, perhaps the way you should have been thinking, where you might have went wrong, to give you some general guidelines on how this paper should have been tackled. And this paper was a difficult one, I do not mind admitting. I think the problem with it was all the skills were legitimate level 1 skills, but they were hidden in some really quite tricky looking questions. But actually the mathematics are not that daunting. First question is a very good case in point. If x equals 4 is a solution to that, find the value of c. All that's saying is put 4 into this expression and see what you get. So let's do that. If I replace x with 4, and I don't know what c is yet, so I'll get what the numbers, and I get c equals 12. And that's all you had to do for that one. This one, quite a tricky one again. A piece of cardboard, need to find an expression for the volume in that format there. Okay, do that. So basically you have to draw a wee diagram, and you notice that if that's x here and that's x here, then that distance is 20 minus x. If that's x there and that's x, then that's 14 minus x. So when you build a cardboard box, you get the dimensions as being x, 14 minus 2x, and 20 minus 2x, and that's the expression for the volume. And all we do there is expand all the way down till we get something like this, dropping out the bottom. 4x cubed minus 68x squared plus 280x. There's no d part. D is just nothing, 0. This one, oh goodness me, a lot of people didn't really get the hint here. The path of a firework is shown. The maximum point is here. It lands 12 seconds after it lands. How many seconds is it higher than 100 metres? So that's this zone here. And nearly everybody says, okay, well, it goes above it at 2, comes below it at 10. So there's the answer, 8 seconds. Well, that's fine. And you got achieved if you said that. But there's a clue here. The clue is all this real estate on the paper seems to suggest it's looking for something a bit more. And it is, because it doesn't actually tell you that it crosses 100 at 2 and 10. You're inferring that from the graph, hence you're getting achieved, but actually you're not told it, so you cannot assume it. Okay, so what are we told? We're told that it intercepts at 0 and 12, so I can form a parabola with some unknown value k using intercept form. I use the point 6180 to get my value of k, which is -5, and now I've got my parabola, and I can set it equal to 100, rearrange it to get it in the form -5x squared minus 12x, that should be, plus 20. Factorise this, and I get x equals 2 and x equals 10, and that is the proof that it cuts at 2 and 10, and that's where we can get our 8 seconds from. Okay, and that's where you can get, I think it's an excellent mark for that one. So if you just read it off the graph, achieved. If you knew to go and do the algebra, you could have got excellence for that one. This one here took me a while here. Find the length of CD. Well, a good place to start is to say, well, BC squared is going to be that squared plus that squared, but a Pythagoras, that's 25. And then you could say, well, look, that's an isosceles triangle. There, it's halved in 2. So using similar triangles, I must be halving the overall length, so it could be 12.5. So if you used similar triangles, you can get 12.5, or you can do like I've done here. I can use a bit of trigonometry and note that the tan of 24 over 7 is 73.74 degrees. It gets me in there, and I can use that to find the size of that side using the smaller triangle up here. Question 2. All we're doing here is putting these values into that expression, and we get an answer of 8628.27. Okay, it's worded really, really challengingly, but all we're doing is putting those numbers into the expression to get that value there. Shape shown as a rectangle, form two equations and then find the values of x and y. Well, the two equations looking for is it's a rectangle, so that must equal that, and that must equal that. So there's my two equations. 2x plus 3 equals 9 minus y, and 3x plus y equals 3y plus 16. That gives me an equation for x and y here, an equation for x and y here, two simultaneous equations. Solve them using the normal methods of simultaneous equations. I can add 2 and 3 there. And I get 7x is 28, x is 4, and y is negative 2, okay? Really straightforward simultaneous equations. I had to multiply this one by 2 here to get that plus 2y minus 2y, but that's how you do it. Tricky one again, that's a tricky one. So we're given a cylinder and we're asked to give the value of that expression over that. So find the volume of a cylinder over the volume of the sphere. Should be in there. So we're told that the surface area of a cylinder, which is 2 pi RH plus 2 pi r squared, over 4 pi r squared, area of a sphere is equal to 2. So we can get that sorted out and we get the value that h equals 3r. And then we can then replace 3r for my h value in here over the volume of a sphere, and a bit of algebra, a bit of cancelling out, and we get 9 over 4. Points A and B have coordinates 2, 9, 10, negative 7, and 6k. The gradient of AB is that, means they're perpendicular. Find the value of k. So, well, if I draw that line in there, and it's going to go 90 degrees, so it's going to go up here. So I'm going to get k somewhere up here. And we're told that the gradient of AB multiplied by the gradient of AC is negative 1. So the gradient of AB is negative 7 is rise over run. It's negative 2. And the gradient of AC is going to involve k. So it's going to be k minus 9 over 4. What I'm going to do is multiply those two things together and put it equal to negative 1, which is what I've done here. So you get k equal to 11. And that looks about right. K equal to 11 looks about the right sort of point up there somewhere. Okay, next. Oh, God, this one, right. Prime factorisation of that. Now, you won't have seen anything like this before. So you just got to work with what you know. It's only an achieved question, unbelievable. So, we know that 198 times k is a square number. So 198 is 2 times 3 squared times 11. So if 198k is a square number, it's going to be 2 squared times 3 squared times 11 squared, right? So that means that k has to be 2 times 11. If that's a square number, we have to square all the parts in it, and the two wee bits I've introduced is an extra 2 and an extra 11. So k is 2 times 11, so k is 22. You know, you're never going to see that. That was just out the blue, that one. Oh, this one here, this is a really tricky one again. If A equals that, find A in terms of x, then B is that, C is that, and D is that. So we're going to drop all these values of B, C, and D into that expression of A and see what we get. Well, 4 times 10 to the power x plus 6 times 10 to the power x plus 1. It's all going on here. We can take 2 out as a common factor there, and that will cancel out with that one. So we've got 2 times 10 to the power x plus 3 times 10 to the power x plus 1. I've got 10 to the negative x in the bottom, which means it's a positive x on the top. So we get 10 to the power x hitting both of them. So we get 2 times 10 to the power 2x, adding the x powers, and then adding those ones, we get 3 times 10 to the power 2x plus 1. Phew, 10 to the power 2x is a common factor. So 2 plus 3 times 10 to the power 1, which is just 30. So it's 32 times 10 to the power 2x. Absolute ridiculous equation. There's other ways to try that, go about that one. That's how I would do it. Well, I see it, that's how I would do it. I'd probably just give up and go home, but if I was forced to do it, that's how I would do it. This one, length of wires cut into two pieces, and the total of all of them is equal to 20. So I've used 4x up in this one, which means I've got 20 minus 4x divided by 4 is each of my sides here. And the total area is 14.5. Okay, so that tells me that so 20 minus 4x over 4 is equal to 5 minus x. So that area plus that area is 14.5. So that's x squared, and that's 5 minus x squared. So all of that has to add up to 14.5. Okay, let's expand this. Gives us a quadratic here. I've got a 10.5, don't like that, so I'll multiply everything by 2. And I can factorise this to give us 2x minus 3, 2x minus 7, x equals 3 over 2, x equals 7 over 2. So the first square has a length of 4 of them, and the second square has got 4 of them. So it's going to be, sorry, that's 6, it's going to be 20 minus 6, so that's 14. And that's the area of the squares. This last question was actually a misprint here. There should have been a couple of numbers added in here, but it doesn't matter, you can still do the question. Okay, what do? Well, we see something, we can factorise this and get rid of the x's, and then that gives us 3x minus 19 over x minus 11. I'm going to put all of these over a single left-hand side, so that becomes 2x plus 10 minus 2x minus 1. Cross multiply, 2 times 3x minus 19, and then that is just 9 here, so it's 9 times x minus 11. Sort it out, and we get 20 and a third for the end of that. And I don't know about you, but I was very glad to see the back of that paper. Now, that's a difficult paper. By any standards, that's a difficult paper. Have we got another question to go yet? No, that's a difficult paper. Basically, if you get any answer, if you get achieved in that paper, you're doing well. Anything in double figures is doing really well, and merit is just a terrific score. That was a really challenging paper, so well done if you managed to get anything from that at all. I think my numbering system's a bit out. That's the problem. Okay, thank you. Better luck next time.